So let's go ahead and look at one more example from section 8.4. So this is problem 4 from the homework in this section, and it says, in a survey of 1,000 drivers from region A, 842 wear a seatbelt. In a survey of another 1,000 drivers from region B, 905 wear a seatbelt. So at the level of significance equal to 0.01, right, is there evidence to support the claim that the proportion of drivers who wear seatbelts in region A is less than the proportion of drivers who wear seatbelts in region B? And it says that assume the samples are random and independent, and we're going to complete parts A through E below. So in part A, it's asking us to identify the claim and then state the null and alternative hypotheses. So remember, the claim that was given in the problem is that the proportion of drivers in region A who wear seatbelts is less than, okay, the proportion of drivers in region B who wear seatbelts. Okay, so that we have an understanding of the meaning of the symbols in the problem. So P1 is the proportion of all drivers in region A who wear seatbelts. Again, likewise, P2 is the proportion of all drivers in region B who also wear seatbelts. So remember, the values of P1 and P2 are unknown because we do not have data on all the drivers from both regions. Okay, but we have a sample of drivers, so a sample of 1,000 drivers from each of the regions. Okay, so to answer the question, right, read the answer choices carefully. Okay, and it looks like answer choice C would be the most appropriate. Okay, so next we're going to set up the null and alternative hypotheses. Okay, so in the claim, right, the words less than are used. So anytime the words less than, greater than, or not equal to, or different from are used in the claim, okay, you translate that to the appropriate symbol and put it in the alternative hypothesis. Okay, so again, if it ends up being a less than, greater than, or not equal to, right, that automatically goes in the alternative hypothesis. Okay, so in the alternative hypothesis, right, the difference between the two proportions, okay, is going to be less than 0. Okay, so you have P1 minus P2 is less than 0. All right, so then what do we put in the null hypothesis? So the opposite of less than, so not less than, would be greater than or equal to. So in the null hypothesis, we're going to put P1 minus P2 as greater than or equal to 0. Okay, so those are the null and alternative hypotheses for our problem. So let's go back to the problem and then select the best answer choice. Okay, so you want the greater than or equal to symbol in the null hypothesis, and then the less than symbol in the alternative hypothesis. Okay, so select the best answer choice. Okay, in part B, we're going to find the critical values and identify the rejection regions. Okay, so this is where you have to decide whether the test is left-tailed, right-tailed, or two-tailed. Okay, and that depends on the symbol being used in the alternative hypothesis. So again, to determine whether a test is left-tailed, right-tailed, or two-tailed, right, you look at the symbol used in the alternative hypothesis, and it's the less than symbol. Okay, so that automatically makes this a left-tailed test. So this is a left-tailed test. Okay, notice how the less than symbol points toward the left. Okay, that's how I know it's left-tailed. Okay, if this were a greater than symbol, okay, it would be a right-tailed test. All right, and if it were not equal to, it would be a two-tailed test. All right, and in any case, right, the claim is represented by the alternative hypothesis. So that's the other thing, right? So the claim is the alternative hypothesis in this case. Okay, and it's a left-tailed test. Okay, so in just a minute, we're going to go ahead and find the critical value of the test. So because it's left-tailed, there's only going to be one critical value. Right, but whenever you have a two-tailed test, there are two critical values. Okay, likewise, if this were a right-tailed test, there would only be one critical value. All right, remember this is based on the level of significance in the problem, which is 0.01. So we're going to do this in StatCrunch once again to get the critical value. So open up the normal distribution calculator. All right, for a left-tailed test or right-tailed test, make sure standard is selected. And then for two-tailed tests, you're going to select between. All right, so it's left-tailed. Select standard. Leave the mean and standard deviation alone, so don't change those. So in this box here, we're going to go ahead and put the level of significance, which is 0.01. And then for a left-tailed test, make sure to select the appropriate symbol and then click compute. So our critical value, when rounded to 2 decimal places, is negative 2.33. So that 2 there at the end, it gets rounded up to a 3. So negative 2.33 will be our critical value. Remember, there's only one critical value since this is a left-tailed test. All right, because it's a left-tailed test, the rejection region is in the left tail. All right, so you're going to select the appropriate option that has the less than symbol being used. Okay, the other two options are not appropriate, but you will select this option for a right-tailed test, and then this option for a two-tailed test. Okay, so there's only one critical value, and we're going to round it to 2 decimal places, so it's negative 2.33. Okay, and the rejection region is where the z value is less than negative 2.33. So you input that critical value in again. All right, so now we're going to enter the information to find the standardized test statistic. Okay, so in StatCrunch, we're going to go to the stat menu, select proportion stats with 2 samples. Okay, with a summary of the data, so we don't have the actual data. Okay, so the number of successes in the first sample was 842, and then the sample size was 1,000. So you put 842 here, 1,000 here. Okay, likewise, the number of successes in the second sample was 905, and the sample size of that second sample was also 1,000. So 905 goes here, 1,000 goes here. Okay, then you select the appropriate symbol for the alternative hypothesis, which is less than. Okay, and we can do an optional p-value plot. Okay, so you can see that this is a hypothesis test for the difference between two proportions. Okay, then it gives you the number of successes and the sample size for each of the 2 samples. All right, and it also gives you the difference between the 2 sample proportions, which is negative 0.063. Okay, but what we want though is a standardized test statistic, which is the z-stat here. All right, and we're going to round that to 2 decimal places as well. Okay, so that 3 gets rounded to a 4, so negative 4.24 is our test statistic. Okay, so based on the value of that test statistic, we're going to compare it to the critical value and the rejection region. Okay, so remember, if we get a z value that's less than the critical value, right, we automatically reject the null hypothesis. On the other hand, if we have a z value, okay, that's not less than the critical value, we do not reject the null hypothesis. Okay, so the critical value was negative 2.33. Okay, so any z-stat or test statistic that is more negative than negative 2.33, okay, is in the rejection region. If it's less negative or if it's positive even, right, it's not in the rejection region. Okay, so what I mean by more negative, it means if you have a larger negative number than the critical value here of negative 2.33, okay, it's in the rejection region. So clearly negative 4.24 is in the rejection region. Okay, so we would reject the null hypothesis. So in part D, it's asking us to decide whether to reject or fail to reject the null hypothesis. So since Z is in the rejection region, okay, we will reject the null hypothesis. Okay, so make your choices from the 2 boxes here. Okay, then in part E, it's asking us to interpret the decision in the context of the original claim. So remember, the claim here is the alternative hypothesis. Okay. All right, so we are rejecting the null hypothesis in favor of the alternative hypothesis. Right. So what that means is that there is sufficient evidence to support the claim. So there is enough evidence at the 0.01 level of significance to support the claim that the proportion of drivers who wear seatbelts in region A is less than, okay, the proportion of drivers who wear seatbelts in region B. Okay, so make your choices from the two boxes here. All right, and that completes problem 4 from the homework in section 8.4. So before we end the video, it's worth noting, okay, so how did we know that our test statistic was in the rejection region of this left-tailed test? Okay, so once again, you can draw a bell-shaped curve with a 0 in the middle. And then the critical value is the cutoff point for the rejection region. So because this is a left-tailed test, the rejection region of our test is in the left tail of the graph, okay, which is shaded in red. Okay, so any test statistic which is less than negative 2.33, the critical value, right, is in the rejection region. Okay, if your test statistic is greater than negative 2.33, it's not in the rejection region. And therefore, you would not reject the null hypothesis. So very clearly, negative 4.24, if you were to plot it on this number line here, right, it would be to the left of negative 2.33, which puts it in the rejection region, okay, which is why we rejected the null hypothesis. Okay. And then our conclusion was that there is enough evidence to support the claim that the proportion of drivers from region A who wear seatbelts is less than the proportion of drivers from region B who also wear seatbelts. So one more thing before I end the video. If you look at the p-value of the test, right, notice that it says it's less than 0.0001. Okay, so notice that the p-value of this test is less than 0.0001. Okay, that's what it says in StatCrunch. Okay, so if you encounter a problem in the homework where it asks you for the p-value, okay, and all it says in StatCrunch is that the p-value is less than 0.0001, okay, and let's say that the homework asks you to input the p-value rounded to 3 decimal places, right? What you would do then is enter 0.000 as the p-value, okay, rounded to 3 decimal places. Okay, so in other words, StatCrunch reports p-values to 4 decimal places. Okay, if your p-value is extremely small, as it would be in this problem, okay, all it tells you is that it's less than this number here, 0.0001. Okay, and once again, if it asks you for the p-value rounded to 3 decimal places, all right, you would input it 0.000 as the p-value. Okay, so in reality, the p-value is not equal to 0, but it's some really small number slightly above 0.